Welcome again to another tutorial. Today we'll discuss autoguiding. So what is autoguiding? In astronomy, we use an autoguider system to compensate for all kinds of errors inherent to our mechanics. Some of it is polar misalignment, some of it is periodic error, some of it is just errors in the gears because the tolerances are not high enough. Some premium mounts and super premium mounts have very small errors, whereas more accessible telescope mounts are going to have inherent quality control issues, if you would. So what we do to compensate for tracking is that we use an auto-guiding system. What an auto-guider does is correct for these errors. So how do we do that? There's three ways to do that. You can piggyback a guiding scope, for example, an Orion 80mm guide scope on top and put an auto-guider camera with it, or you can be off-axis or on-axis. The last two mean that the guide camera is looking through the same scope as the main imaging camera through either a pick-off prism or what we call a dichroic mirror. So how to set it up in Prism? It's fairly easy. Let's connect the simulator camera. Let's connect the simulator telescope mount, that is. Here we go. Let's minimize this. So to calibrate your guider, you need to head due south. So we'll press this south button up here. And typically you want to be around declination 0. So there are two ways to find where declination 0. One is to just move your mouse here and look at the information bar down here, and you can see where it's at. So here's declination 0-ish, and it doesn't have to be dead on declination 0. It could be plus or minus 15 to 20 degrees. The other way is to head to here to settings, general display, and show RAN dec grid right here. When you do that, this is declination 0 right here, or the celestial equator. So let's move the mount here. So we'll choose a point and we right click and tell it to go slew telescope to this point. Here we are. So we'll go to the simulator camera, press the guide tab, and the guiding tab, and press calibrate here. This pop-up shows up. So this asks us how much time do you want to move the RA axis. Excuse me. How much time do you want to move it in dec? If you want to do any mirrors. This is a 3x3 median filter, just in case you have hot pixels in your auto-guiding camera or auto-guider, whereas you can apply darks using the built-in shutter. You can smooth it out with this. You can tell Prism not to do any centroiding, and you can do FFT calibration, which means that you don't choose any stars and Prism detects them automatically. For cameras that have a shutter, this is disabled. For cameras without a shutter, you can actually take some dark frames and stack them and make a master dark frame, and Prism will take it and use it to clean out all the hot pixels from your guider. If you by the way, here's binning as well. If you choose to bin your camera 2x2, you can. In the advanced tab, now in this tab, you have to absolutely know this information about your mount. This is very advanced, and you really need to know everything about it. So if you set up your guider in some definite angle, then you know where the angles are. You can enter them manually here. For this presentation or tutorial, we'll avoid that. Here we go. Let's press OK. Prism will take a picture, This is a dark, and it subtracts it, and then it asks us to pick the star that we choose with these crosshairs. So press on it. It'll move it for the interval that we told it earlier, and then you'll take an exposure again. Choose the same star. This calibration needs to be done one time. So if you have the same setup and you don't move the auto guiding camera and it remains on the same off axis, on axis, or guide scope, and you do not touch it at all, this calibration is good for as long as you want. So this is a one-time calibration. We'll press on the same star again, and its calibration is completed. So here's a graph of what happens. So it starts from one position, takes an image, then takes off, takes an image, takes an image, keeps going, takes an image, and goes back to the same point and takes an image. If this parallelogram is close to being closed, then it will be successful. If, for example, the last point ends up here or here, it will fail. There's an indicator. That is an indicator to the deck backlash most of the time. So what can we do to do that? Well, you can mechanically fix it in your mount by adjusting the meshing, or you can increase the calibration time in declination until it actually succeeds. This is the only way to overcome it. These two ways, increase the time or mechanical adjustment. So let's try and guide. Let's take a 1 second exposure, and remember this is a simulation run. Let's press start, and here we are. We can choose to press start, and we can tell it what star to pick, or you can press try and find guidance star automatically. Let's press start. In this window, we need to adjust the settings that pertain to guiding, what we want the guider to do. Let's start from the left side. So the information is the calibration and with what system was it calibrated. Image capture. So we will either put a window around the star, say we pick this star over here, we'll put a window around it, and we'll only guide on the star, or you can choose a full frame. So let's choose a 50 by 50 pixel window. Capture delay in seconds. So when Prism takes an exposure and it makes a correction, it waits the set amount of seconds you set here. Parameters to be used for calibration. So there are no mirrors, and the binning is 1 by 1. Here's dither. How many pixels do you want to dither? This is random in both RA and DEC. I set it to 3 pixels for now. Right ascension axis. So aggressiveness, this is between 0 and 2. If I choose 0.5, that means it only applies 50% of the correction from the observed error. So if you have a mount that tracks really well, this might be a good idea. Some less performing mounts might need a little bit more aggression, which is 0.8 or 0.7. Minimum pixel shift for move in pixels. So this setting tells Prism if the mount moves 0.2 pixels from the reference point, make a correction. So if your mount is guided really well and it does not exceed 0.2 pixel, then Prism does not make any corrections. This is the maximum amount of pixels before Prism tries not to correct anymore. Just say there's a gust of wind and it knocked the telescope away from the target, and the target is not centered anymore anyway, so might as well restart guiding. So we'll set this to 20 pixels. Here the deck compensation is done automatically, so it knows exactly where the declination is, so it knows which corrections to make. So this is the shift computation method. Do we use the centroid of a star that is calculated, or do we do FFT guiding? So let's just use centroid for now. And FFT guiding uses the entire image and all the stars in it. Something to note, your stars need to be in decent shape for this to be successful and to guide effectively. If you have an off-axis camera and the stars are comet-shaped or seagull-shaped, you might revert better to centroid guiding for that instance. Let's carry on. Deck axis. Well, the same settings are available for the deck as well as the deck backlash compensation in pixels. There are some specific options here. One of them is do not flip the mount. This is in case that the data is flipped in the SkyX, so that we don't do a double flip after a meridian flip for paramounts. If you have a paramount, you might want to check this. This is to tell Prism that if the mount flipped since the calibration occurred, if you did the calibration and then you flipped the meridian, that will be checked automatically. If you have really good polar alignment and you don't want the declination to move at all, you can just check this setting and then it'll tell you, warning, image dithering is not compatible with single axis deck moves enabled. Bear in mind that this dithering setting is for RA and deck and it's random. So this will negate this. Prism includes a very powerful deck drift algorithm. What it does is that if you know which way you're drifting, you can choose these settings automatically. So say deck is always drifting north, so you do corrections only south, and so on and so forth. Some people choose to do that. But Prism has a third option, it's automatic corrections. If you can tell it if the deck drifts 0.5 pixels for 3 iterations, I want you to make a correction. Now bear in mind, this automatically defines which way the drift is happening and compensates automatically. This is really good for automated imaging, to where you flip the meridian, go to the other side. Just imagine you set it manually and it was correcting north, and then you flip the meridian, and then now you're doubling your errors because it's drifting north and you're adjusting north as well. So this is your go-to option to remedy that. If you use a derotator, it'll be automatically populated here, no problem there. You can choose to have sound alarms if guiding gets lost, just in case you're imaging and you're sleeping in a tent, you want an audible noise, and trust me, this will wake you up. You can choose your own audio files, and that will be covered in another video for setting up all the settings of Prism. You can choose to perform a 3x3 median filter to the image to just negate any hot pixels, cold pixels, and so on and so forth. Now to the advanced tab. You can do fixed guiding on a position in the image if you choose to. It's just a simple square in the actual image to where it guides on it. You can have adaptive optics. You can log automatically your recordings from your guider just in case you are having problems, and this will go into here. It's the documents, Prism, and guiding underscore log, and that's where all these images are going to be recorded. Centroiding. Enable enhanced centroiding position. Warning, this is requiring perfect focus star shaped on CCD guider. So that's a warning there. You can also guide on the slit. Right here, you can tell it exactly the position, if it's a vertical slit, if it's a horizontal slit. And these options here are image capture loop, actions between captures, slit centering, integer position in Y and X. Right here you can set it in pixels, number of attempts, CCD guiding exposures for guiding star recentered during loop. So it'll try for like 18 times before it gives up, tries to bring the star back. This is a night where you're guiding, there's a subframe, a gust of wind hits, the star jumps out of the frame, and Prism will try for 18 times to bring it back. If not, it'll just abandon and try and recover. So this is, yeah, you can set this if you wish. Now let's start guiding. Let's see what happens. Press OK. Here we are. Takes a dark, subtracts it, takes another dark, and here we are. We're guiding. All right. So the top is your RA axis, the bottom is your deck axis, and this is the flux of the star. Prism is measuring the flux of the star in each exposure, and obviously the higher the better. What happens here, if there are very high clouds that go in front of the star, the flux diminishes and this starts to go down. This is a really good indicator of your guiding at the time. This up here is a 2D representation of the guiding. So this is 1 pixel right here. The graphics, if you choose a more conventional guiding to where these are separated, you press graphics. And here we are. This is more conventional if you wish to use it this way. You can reset the graph and you can save it as well. This shows you the shift in pixels and angle, just to see if, for example, all your guiding errors are in one direction, to give you an indicator. It calculates the average direction again to help you define which way it is. Is it north, east? Is it a balance issue? Is it a backlash issue? This here gives you the average tracking error. Remember that this value is everything that is displayed here, which means if you have voluntary dithering, that will also count. I will show you another way of seeing what happens, what the RMS error is for just your exposures. And this is cloud monitoring, so it measures it in ADUs and RMS as well. So for advanced options now, press more. You can have a bunch of information here about your guidance session. I'll tell you which way it's correcting. You can stop the log, you can save it, and this is a bunch of extra information. Now, if you go to controls, you can change these controls on the fly. These are aggressiveness, and this is the time. Let's change time to 3 seconds, for example. And I think the guidance is a little bit aggressive, so let's drop it to 0.2. And let's drop our deck to 0.3 and see what happens. Press apply, and here we are. They changed. Calculations. This is the RMS error of your guidance session. So now you see it's green because it's just guiding. There were no exposures being taken. But if we go to main CCD and start a 60-second exposure, this will switch to red. Well, here we go. It's the deflection we spoke about earlier. There we go. It's back. So try to recover. There we go. So now it's switching to red. Red means it is actually recording the RMS errors and an exposure is being taken. So these are the RMS values of your errors in this exposure right here. So any red. Display, we can let it display like this, which is automatic, so it automatically adjusts the scale for the errors, or we can just manually force it to be just 1 pixel, or if you wish 2 pixels or 5 pixels, whichever one you wish. This will force it to be a thick red color if you have visibility issues with the graph. And then you can display the actual points of your graph as well. Sharp lock. This is a technology that is also included in Prism, and it allows you to use a special lens, if you would, on your lodestar. and this will calculate which way the focus is going, as well as guiding. And this will allows you as well to adjust focus at the same time as this is happening. I will refer to this in the description, and I will not go any further into this because this is a product sold by a third party, and I'll let you read up on it. But this is also included in Prism. So we covered today how to set up Prism and how to guide in it. Again, hope this helps. If you have any questions, hit me up. If not, I will see you on the next one. Thank you very much for your time. Have a great night.